Mathematics is the foundation of our modern world. From nature to technology, business to medicine, math is everywhere. But how does it shape our daily lives? Come on, let's explore. Throughout the history, mathematics has revealed the hidden patterns of nature and the universe. One such remarkable discovery is the Fibonacci sequence, a series of numbers that holds a mysterious yet practical presence in our daily lives. The Fibonacci sequence was introduced by an Italian mathematician named Leonardo of Pisa, later known as Fibonacci. In year 12,002, he published a book titled Liber Abaci, or the Book of Calculation. In it, he presented the now famous sequence 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. Each number is the sum of two preceding ones. How does Fibonacci sequence affect our daily lives? In our everyday life, this sequence finds practical applications. For example, in finance, it helps traders identify potential market retracements using Fibonacci retracement levels. In architecture and design, the golden ratio closely related to the sequence is used to create aesthetically pleasing structures. Throughout nature and human creations, we find captivating patterns that reveal an inherent order. From petals of a sunflower to the architectural wonders of cathedrals, mathematics governs the symmetry, balance, and elegance of our world. In this exploration, we will dive into four remarkable concepts: the Fibonacci sequence, man-made patterns, bilateral symmetry, rotational symmetry, and the mystical golden ratio. And so, the legacy of Leonardo Pisa lives on, reminding us that numbers, patterns, and natures are forever intertwined. Let's begin with the Fibonacci sequence, a series of numbers that forms a foundation for many natural patterns. The sequence begins with 0 and 1, and each subsequent numbers is the sum of the previous two. Now, I will let Justin discuss more about the Fibonacci sequence.
Fibonacci sequence is mathematically expressed by the formula if n equals f or n minus 1 plus f or n minus 2. For example, f or 6 equals f5 plus f or 4 equals 5 plus 3 equals 8.
While the Fibonacci sequence occurs in nature, humans have also incorporated it into man-made patterns. The Fibonacci spiral, derived from the sequence, is used in architecture, paintings, and design for aesthetic balance. One famous example is the Parthenon in Greece, whose dimensions follow the Fibonacci ratio, creating a visually pleasing design.
The man-made pattern solution. Example, draw a Fibonacci spiral. Number 1. Start by creating square with side lengths equal to Fibonacci numbers 1, 1, 2, 3, 5, 8, and so on. Number 2. Connect quarter circle arcs from corner to corner to form a spiral. Golden rectangle and arc. This dimension of the golden rectangle follow the ratio, giving it a harmonious appearance. Example, Leonardo da Vinci's Vitruvian Man and the placement of features on the Mona Lisa use the golden ratio.
The proportions of the human body in this famous drawing are based on the golden ratio. The figure is designed to fit within both a circle and a square, showcasing ideal human proportions many of which are linked to the golden ratio. Leonardo da Vinci is also believed to have used the golden ratio in the composition of the Mona Lisa. The positioning of her face, hands, and the surrounding background elements are thought to follow the principles of the golden ratio, creating a balanced and harmonious composition.
Now, let's explore bilateral symmetry, a form of symmetry where an object can be divided into two identical halves. In nature, we see this in butterflies, human faces, and leaves. Bilateral symmetry provides balance, aiding in movement, efficiency, and visual appeal.
Bilateral symmetry. Bilateral symmetry solutions and example. Example number 1. Symmetry in butterflies. If you divide a butterfly down the middle, both halves mirror each other. Mathematically, this symmetry can be described by the line or any vertical line dividing the shape in two identical halves. Example number 2. Human face symmetry. The left and right side of most human faces are nearly symmetrical, though mirror asymmetries exist.
Next, we have rotational symmetry, where a shape looks the same after being rotated by a certain degree. Many flowers, snowflakes, and pinwheels display this symmetry. For example, a starfish. A starfish has a 72-degree rotational symmetry, as rotating it by 72 degrees results in the same shape.
Rotational symmetry. Rotational symmetry examples and solution. Example number 1. Rotational symmetry in a star. A regular 5-pointed star has rotational symmetry of order 5. It repeats itself every of rotation. Example number 2. Snowflake. Snowflake have a 6-fold rotational symmetry. Rotating them by result in the same shape. The formula for rotational symmetry is angle of rotation equals 360 degrees over n.
Finally, we arrive at the golden ratio, a mathematical constant approximately equal to. It is denoted by the Greek letter P. The golden ratio appears when the ratio of two quantities is the same as the ratio of their sum to the larger quantity.
Golden ratio. The golden ratio formula is pi equals a plus v over a equals a over b approximately equal to 1.618. Golden ratio examples and solution. Example number 1. Golden ratio and rectangles. If a rectangle has side with lengths in the ratio, it is a golden rectangle. Example number 2. Fibonacci sequence and the golden ratio. As the Fibonacci sequence progresses, the ratio between consecutive numbers approximates the golden ratio. F of 10 over f of 9 equals 55 over 34, approximately equal to 1.6176 or 1.6176.
Our topic is not that bad, isn't it? As we've seen, mathematics is not just a theoretical concept, it shapes the world around us. From nature's symmetry to human design, the Fibonacci sequence, bilateral symmetry, rotational symmetry, and the golden ratio reveal the hidden beauty of the universe. Mathematics truly is the language of nature and creativity. I hope you learned something from us today.